Hi guys! Alright, I'm so excited that we're already working on lesson number 9 in module 4. This one doesn't have any opening exercises, it doesn't have any exercises built within it. It's just examples and then the problem set. So it's going to be a lot of me talking. Feel free to pause to write things down, pause to, go back so that things make sense. If you need to pause and just take a break for a second, that's totally fine. But I'm not going to have to show you that, pause now kind of board, okay? So just a heads up. So let's just dive right into it. Example number 1, create a bar diagram to show 3 plus 5. So I'm actually going to use some different colored markers to make sure this is super clear. So if I wanted to do 3 plus 5, I'm going to start out 1, 2, 3 with my green, and then with my red it would be 1, 2, 3, 4, and 5. Kind of ran out of space there, but that's all right. So this is 3 plus 5, right? So I can take my black marker and write my answer, or my problem, 3 plus 5, right? Now, if I wanted to do 5 plus 3, what I would do instead is I would start out here with 5. 1, 2, 3, 4, 5, and then move on to the red. 1, 2, and 3, like that. This is 5 plus 3. Okay, so you guys notice the difference between 3 plus 5, 5 plus 3. Hopefully you can tell. The 3 goes first here, the 5 second, and in this case it goes the other way around. Whatever number's first is written first in your bar diagram, right? Okay, great. We've completed, what is that, like first grade math? I'm glad we can add numbers, but I promise you there is a reason to this. So let's look at example 2. We're going to get kind of a harder problem, hopefully, somewhere in here. So how can we show a number increased by 2? Oh. So it doesn't tell us what number is increasing by 2. Do you guys notice that? Because we don't have a number, I'm just going to take the letter A, because that's the first letter in the alphabet. Let's start with A. A plus, actually I should probably take this, A plus 2. A plus 2. That's some number, A plus 2. Now, how would I do this using a model? Well, here's my unknown number, and I'm going to add 2, which I do know what 2 looks like. 1, 2. So I've got A plus 2. I could also write that as 2 plus A. Both ways would have been fine. Okay. So, great. Addition with an unknown number. So, let's look at example 3. Write an expression to show the sum of M and K. So sum means adding. So sum of M and K is going to be M plus K, or it's going to be K plus M. Either way, right? I know it can be either way because, and here's the next question, what property can be used in examples 1 through 3 to show that both expressions given were equivalent? This is called the cumulative property of addition. We learned this before, but I'm going to write this, commutative property of addition. Commutative property of addition. This would be a good time to pause it if you need to, so that you can spell this correctly. Commutative property of addition. All right. example number 4. How can we show 10 minus 6? All right, so for this one, I'm going to start out, well, I'll start with my green because I've been starting with green. Actually, we're going to make it nice long. I know we're going to need a lot here. I'm going to make this more like fractions just because it's easier for me. 2, 3, 4, 1, 2, 3, 4. All right, so there we go. Now we've got 10. Much faster than drawing out each individual box. So we're drawing our bar diagram. We've got 10, but we are subtracting out 6 of them. So I'm going to kind of shade in. Here's 10 right here, right? What I'm going to do is I'm going to shade in. I'll take my red to do this. I'm going to shade in 6. 1, 2, 3, 4, 5, and 6. Like that. So, what expression represents this model? 10 minus 6, right? Can we rewrite this as 6 minus 10? No. Of course not. If we did 6 minus 10, we'd end up in the negatives. That model just wouldn't work, right? So, we know, because we know subtraction, because we passed first grade, we know we can't rewrite it. It's not the same model when we do. All right, well, so then example 5 leads us to how can we write an expression to show 3 less than a number. Okay, so when we are finding 3 less than a number, we just did 6 less than 10. 3 less than a number, we don't know that number. I'm going to do n for number, okay? N minus 3. So I can draw this. I'm just going to stick with my black because I don't want to keep switching. Here's my number, n. I don't know what number that means. It could be 2, it could be 1,000, it could be negative 62.5. I don't know. And honestly, I don't care what number it is because this is going to be true no matter what. So n is this some amount. And you say, okay, here was 3. Take away 3 out of it. You can kind of see that 3, y'all. I'll go like this. We'll shade it in all the way. Sorry if you guys can hear that train in the background. So I'll take away 3 like that. There we go. So we are taking 3 away from the unknown number. Okay? Because of that, the only expression we can use is n minus 3. We can't use 3 minus n. That's taking n from 3. We're taking 3 from n. It's a different thing. Just like taking 6 from 10 is different than taking 10 from 6. The same principles in addition and in subtraction apply even when the number is an unknown number. Math stays the same no matter what that number is. Those same properties still exist. Okay? So even if it's a number you don't know yet, the properties are still the same. Let's move on to example 6 and we'll be able to see this again. So how would we write the expression to show the number c being subtracted from the sum of a and b? Whew, all right. Now we're getting into some hard math. All right. So it says first, start by writing an expression for the sum of a and b. Great. Sum of a and b. Sum is addition. So I could do a plus b. Right? I could also do b plus a. Right? We know both of those are true. We already looked at the commutative property of addition. So now we need to show c being subtracted from the sum. Okay? Minus c. Minus c. Okay. Great. No problem, right? Let's look at example 7 though, because look at this, write an expression to show C minus the sum of A and B. Okay, well, so we start with C minus, but here I'm going to add A and B on their own because we want the sum first. C minus the sum of this. So because I know it's minus the whole sum, I need to do like this. I need to have those parentheses. If it had been C minus A plus B, or the sum of C minus A and B, then it would have been C minus A plus B like this. But because it specifically says C minus the sum of A and B, that sum of A and B has to be in parentheses, okay? I know it didn't seem like it mattered here. That's because the addition came first. But because that addition's coming second, it really does have to be in parentheses there. The parentheses are necessary because without that, only A is being taken away from C. Think about that. Without parentheses, if I had done it this way, it would have been C minus A, that part's subtraction, and then they add in B. It might potentially change the value of your expression depending on the numbers if you don't have this in parentheses. So we do have to make sure that we're subtracting all of this together because that B is being subtracted here. It's not actually being added to a C. So that's really important to know. Let's try this. We're gonna actually try that out. I'm gonna write down C minus A plus B like this versus how it is in parentheses. I think that might help make it super clear why there's parentheses in this case. So let's say C is 6 and A is 5 and B, let's make A 2, sorry. A is 2 and B is 3. 6 minus 2 plus 3. So we have to do 2 plus 3 first. We know it's 5. So 6 minus 5, that gives me 1, right? But if I did the same thing here, so C is 6, A is 2, sorry, and then B is 3, 6 minus 2 plus 3. So 6 minus 2 is 4 plus 3. That gives me 7. Holy cow. Do you see that? So in my first one, with the parentheses, it ended up being equal to 1. But the second one, without parentheses, is equal to 7. Same numbers. I'm doing the same things. It looks like I'm adding and I'm subtracting. But look, because I had those parentheses, it totally changes the values. That's true for so many different numbers. Those parentheses are so important. So in example 7 and in example 6, well, yeah, more example 7, I guess. It's so important we start including those parentheses because it says the sum of A and B. Okay? So that's really the goal, is that you understand the value of parentheses and you understand that the properties of addition and subtraction remain the same even when you're using variables, even when your number is an unknown number. Okay? The properties of addition and subtraction, the importance of having parentheses does not change simply because you don't know the numbers. Okay? Okay. Well, you now move on to some exercises and your problem set. The problem set's 7 questions, but really looking through it, it shouldn't be a ton. And your exercises, it's saying that it's 8 problems, so it should take about 12 minutes is what it suggests. I know that might take a little bit longer because you're at home. I also know that it's possible you have some questions. So if you've got any questions, please email me, ask me in whatever way you can. I am here to help. I will do whatever I can to help you, okay? All right. Have a good day.